Think about the biggest thing you can imagine. A skyscraper, Mount Everest. Now imagine something even bigger, much bigger. The universe is so vast that it's hard to grasp its size. But don't worry, we're going to take a journey from the tiniest particles to the largest structures in the cosmos. Imagine a measuring stick that can stretch and shrink. We'll use it to compare everything from atoms to galaxies. Along the way, we'll discover amazing facts and get a sense of just how enormous our universe truly is. Get ready for an adventure through the scales of the universe. Our journey starts with the fundamental building blocks of everything around us: atoms. These tiny particles are so small that millions of them could fit on the period at the end of this sentence. From there, we'll zoom out to larger and larger objects, comparing their sizes and appreciating the incredible scale of the universe. So, fasten your seatbelts and get ready for an awe-inspiring journey through the cosmos. Let's start our journey with the incredibly small atoms. Atoms are the basic building blocks of everything we see and touch. They are so tiny that a single grain of sand contains trillions upon trillions of them. Imagine shrinking down to the size of an atom. You'd be surrounded by a bustling world of electrons orbiting a nucleus. To understand just how small an atom is, consider this. If an atom were the size of a football stadium, the nucleus at its center would be about the size of a marble. The rest of the space would be occupied by electrons, buzzing around the nucleus like tiny bees around a hive. Atoms are incredibly small, but they combine to form everything we know. They join together to create molecules, which are the building blocks of matter. For example, water molecules are made up of 2 hydrogen atoms and 1 oxygen atom. From these tiny building blocks, the universe creates everything from the air we breathe to the stars in the sky. Our journey through size is just beginning, and it's about to get much bigger. Moving up in scale, we encounter cells, the fundamental units of life. Cells are much larger than atoms, but they are still incredibly small. A single human hair is about 100,000 times wider than a typical human cell. Inside each cell, a complex world unfolds. Organelles, the tiny organs of the cell, carry out essential functions like energy production and waste removal. It's like a bustling city operating within a microscopic space. To get an idea of the difference in size between atoms and cells, imagine this. If an atom were the size of a grain of sand, a cell would be about the size of a house. That's a huge jump in scale. Trillions of cells work together to form the tissues and organs that make up our bodies and all living things. From the tiniest bacteria to the largest animals, life relies on the intricate workings of these microscopic units. Our journey now takes us to a familiar place, Earth. From space, Earth looks like a blue marble, a beautiful sphere of land, water, and clouds. But just how big is our home planet? Earth has a diameter of about 8,000 miles, which means you could fit about 7.5 trillion Earths inside our sun. That's a lot of Earths. To put it another way, if you could shrink the Earth down to the size of a basketball, the moon would be about the size of a tennis ball, orbiting about 7 feet away. Even though Earth seems vast to us, it's just a tiny speck compared to the objects we'll encounter next in our journey through the cosmos. Buckle up, because things are about to get even more awe-inspiring. Section 5. Planetary Neighbors, the Solar System. Zooming out from Earth, we encounter our planetary neighbors in the solar system. Our solar system is like a giant cosmic park, with the Sun at the center and 8 planets orbiting it. The largest planet in our solar system is Jupiter, a gas giant so massive that you could fit over 1,300 Earths inside it. Saturn, with its magnificent rings, isn't far behind in size, but even these giants are dwarfed by the Sun, which contains over 99% of the mass in our entire solar system. To visualize the scale of our solar system, imagine shrinking the Sun down to the size of a grapefruit. Earth would be about the size of a pinhead, orbiting about 50 feet away. Jupiter would be like a marble, orbiting about 250 feet away, and Pluto, the farthest dwarf planet, would be a tiny speck almost 2,000 feet away. As vast as our solar system seems, it's just a tiny neighborhood in the grand scheme of the universe. Get ready to explore the realm of stars, where sizes reach truly mind-boggling proportions. Section 6. Stellar Giants, Stars. Our Sun is a star, a giant ball of hot gas that emits light and heat. It seems huge to us, but it's just an average-sized star compared to some of the stellar giants out there. One such giant is Betelgeuse. a red supergiant star located about 640 light-years away. If Betelgeuse were placed at the center of our solar system, it would stretch all the way out to Jupiter, engulfing Mercury, Venus, Earth, and Mars. And Betelgeuse is not even the biggest star we know of. VY Canis Majoris, a red hypergiant star, is so large that you could fit over 1 billion suns inside it. It's hard to even imagine something that big. Stars come in a wide range of sizes and temperatures, from tiny, cool red dwarfs to massive, scorching blue supergiants. Our Sun is just one of billions upon billions of stars that make up our galaxy, the Milky Way. Section 7. Island Universes, Galaxies. Galaxies are vast collections of stars, gas, dust, and dark matter held together by gravity. Our Milky Way galaxy is a barred spiral galaxy, a majestic swirl of stars and gas that stretches over 100,000 light-years across. To get an idea of just how many stars are in our galaxy, imagine this: if you counted one star every second, it would take you over 3,000 years to count all the stars in the Milky Way. And that's just our galaxy. There are billions upon billions of galaxies in the observable universe, each containing billions or even trillions of stars. These galaxies come in a variety of shapes and sizes, from elliptical galaxies to irregular galaxies. They are like islands of light scattered throughout the vast cosmic ocean. Our journey through size is nearing its end, but we have one final stop: the observable universe. Prepare yourself for the mind-boggling vastness that awaits. Section 8. The observable universe, mind-boggling vastness. The observable universe is everything we can see from Earth, limited by how far light has had time to travel to us since the Big Bang. It's estimated to be about 93 billion light-years in diameter, which is a truly mind-boggling distance. To put that into perspective, consider this: if you could travel at the speed of light, it would take you 93 billion years to cross the observable universe. That's longer than the age of the universe itself. Within this vast expanse of space, there are billions upon billions of galaxies, each containing billions or even trillions of stars. And around many of those stars there may be planets, some of which could even harbor life. The observable universe is a humbling reminder of just how small we are in the grand scheme of things, but it's also an inspiring testament to the incredible scale and beauty of the cosmos. Section 9. Our place in the cosmos. As we conclude our journey through size, from atoms to the observable universe, it's important to reflect on our place in this vast cosmos. We've seen that Earth is just a tiny planet orbiting an average star in a vast galaxy among billions of others. The universe is a place of incredible scale and beauty, full of mystery and wonder. It's a cosmic ocean teeming with stars, galaxies, and perhaps even other forms of life. As we continue to explore the universe, we gain a deeper appreciation for its vastness and our place within it. By understanding our place in the cosmos, we gain a new perspective on our own lives and our responsibility to care for our planet and each other. The universe is a vast and awe-inspiring place, and we are fortunate to be a part of it.